Okay, so here's one of these microcare solar pump controllers. Damn fine piece of equipment, but if you use it in a really hot place like I do, you run into these problems here. The unit cleverly powers down when things get a bit hot, and mine, for example, at 86 degrees C drops right down to 3385 watts, where it's actually a 5.5 kilowatt solar pump controller. So I came up with a hack to solve that problem. So here's what I came up with. It's a plastic bucket basically, and in it is a heat exchanger. You can just see through there I've got a series of copper pipes. I'll show you in a moment when I open the top. But I've got cooling water coming in to this point over here and exiting down the road there, and thereby cooling the system rather nicely. Let's show you inside. So there's the solar pump controller. Now you'll see it's in oil, but not too deep, because obviously you can't have the electronics in oil, and the circuit board is horizontal at the moment, the way I've placed it, and the oil level is just high enough to not touch the circuit board. And beneath it you'll see the solar pump controller is sitting on a series of copper pipes which I've soldered into a heat exchanger. So the heat transfer occurs through the oil from the fins on the back of the heat sink, because now those fins are sitting in oil, and then the oil in turn is cooled by the water which circulates through. And after all, seeing as you are pumping water with this device, there's no shortage of water normally on site. And here you'll see the flow rate that I'm using. So that water is lost effectively, but the beauty is it's pretty cold when it comes out there, even in a place such as this, which is 45 plus degrees today. That solar pump controller can run full power and do its thing. So a nice hack to make a good product even better. And one last thing, you want to avoid trapping air in this heat exchanger. Because it's lying horizontally, it could very easily get air trapped in there. So what I do to prevent that is, at the highest point, the supply line I loop upwards, and at the highest point I've put in a little outlet there which goes to a little sprinkler which you can see over there. And in the morning when the system fires up and there's possibly a little bit of air in the line, the air should find its way out at that point and not go down into your heat exchanger, because if you have air inside the heat exchanger, it's not going to work. So you have to bleed the system, tip the heat exchanger so that the exit pipe, this one over here, is the highest point, and you'll hear the bubbles escaping, and then it should be good to do its thing. Okay, good luck with that.